They got in over break. We are moving on to our next unit. That's kind of the vibe. So at the top of this packet has a sentence where it talks about the definition of limits. It just says next to the title here, not homework, don't turn in. I don't need, this is your notes, I don't want it. There's a line for your name just in case it gets lost, I can get it back to you. That's the only reason I have a name line on there. So this is the line I'm talking about. A limit is the, and then a blank. And what a limit is called, it is the y value of a function as the function, the y value of the function approaches as x approaches a given value. So we will give you usually either an equation or a picture. Today we're going to work from pictures, tomorrow we'll work from equations. And we're going to try and figure out what y value x is approaching. There's reasons we say approaching, not at. And so we're going to look at this picture down here, and we have this kind of table-looking thing of answers. These are the questions we're answering down here. So I kind of have them broken up into columns, 3 columns. This is the picture we're looking at. All these things. So the limit is the y value the function approaches as x approaches a given value. There is not a way to do kind of a generalized limit saying this works for every x. It will always be to a specific number or to like infinity, meaning ends. And how limits are written is we write limit, and as x approaches, this would be our given number. This is the number we're looking at. This is that given number. And then here would be our function, either f of x, or it might be g of x, h of x, whatever. Might be an equation, it might just say f of x, it might just say g of x. But that's going to be our function rule. Sometimes on our given numbers down here, we see these at the bottom, there will be what looks like a little exponent up here, either a plus or a minus. I'm not going to put P right here. It kind of looks like a power. If that says plus, that means we are coming at it from the right, from the positive side. So looking at it from a certain direction, from the right. So if it has a plus up there, it's going to be coming from the right. I promise I will talk through everything specifically. I'm going to rewrite the word right because that looked crazy. If the P has if it's a minus sign, like it's not going to have a number up there, it's just going to have a plus or a minus, that means we're going to go from the left. If it doesn't have a sign up there, it means literally from both. It's going to match. So it's going to have some kind of weird looking notation. There's a few examples of it at the bottom. Those are going to be the ones we answer. So the minus signs are all very, very faint, but like the top row has the little minus sign, kind of like an exponent on the bottom. The bottom row has the little plus sign, kind of like an exponent on the bottom. And the bottom row doesn't have any little sign on it. So it looks really weird. I promise it looks way more complicated than it is. So let's take a look at this picture right here. I'm going to put it up on the big screen. Anybody need more time on this before I change it? Got it. I'll wait. We're good. Cool. All right. So we're going to look at this picture. This is the same one that's on your notes packet here. And this is the leftmost column at the bottom. So these are the questions that are down here. There's not like a ton of work to show here. A lot of times your answer is just going to be a number. So the first thing we're asked is something we have seen before. So we want to know what g of 2 is. What is g of 2? If this function is g of x. This guy's g of x. Let's say we're looking at the right spot. I heard two different answers. We're looking exactly at the right spot, both of us. Where is the actual answer? 3. It's where it's filled in. So at g of 2, the answer is 3. That's where our colored in dot is right here. What the limit's going to let us look at is it's going to let us look at each piece kind of individually. So this one says, what is our limit for g of x, our function, as x approaches 2, minus as a power means from the left. So this means up here, from the left. So I can trace my function, if I trace my function, I can trace here, and then we've got this discontinuity and this discontinuity, and I can trace it. If I'm approaching 2 from the left, I'm coming at it from this direction here. So if I'm approaching 2 from the left, what am I getting really, 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 really close to? What y value am I approaching? 1. So the limit, as we approach 2 from the left, is going to be 1. That's as we get closer and closer and closer and closer and closer to 2 on my x's. So I'm just going to make that chunkier. It's approaching 1. So our limit is 1. Because that's where it would hit if we didn't have that discontinuity. When we're approaching it from the right, which is what the little plus means, this one means from the right, so now I'm tracing back the other direction. So I'm not on this line anymore because I can't come at it from the right over here. I need to come up here where I'm on the line. So I'm on my function as it approaches 2 from the right. What y value are we approaching? 3. So the limit for g of x as it approaches 2 from the right is 3. If it does not have a sign, it's trying to look at both at the same time. We will only have an answer for ones that don't have a sign if these two are approaching the same number. These two are not approaching the same number, which means that limit does not exist. There is not a limit as g approaches 2 because it's going 2 different places. So if it's not approaching the same number, the limit does not exist. I gotta think of Mean Girls on that one. The limit does not exist, I know. The limit does not exist. Thank you, Mean Girls, for making that popular. The limit does not exist. The limit does not exist. There is a T, I don't know what it says there. Apparently I've forgotten how to screen. Mean Girls.
Oh, I watched that.
Yeah. That's when she's like staring at him and then he like fives out because she's in the math competition. It's like, October 3rd, the limit does not exist. That day. That's right. Yeah. Okay, we're going to practice this several more times. We're going to look at other values. So this is looking all at 2. All of these we're looking at 2 right here. The next one we're going to look at is very similar. We're just going to look at 3. Questions on this one before I change the page? I can always bring it back. So we're looking now where x is 3. So very similar vibe. First thing we want to do is we want to find our g of 3. What is g of 3? 2. When x is 3, the value is at 2. It absolutely is. So g of 3 equals 2. That is where our point is. The filled in point is where our answer is. The colored in dot. So now we're going to approach, we want to know the limit for g of x as x approaches 3 from the left. When we have the little minus sign, remember, when in doubt, the minus sign is negatives. Negatives are on the left side of the number line. Positives are on the right side of the number line. That's what we mean by from the left, from the right. It's based off the number line there. So from lower values, from negative values, from smaller pieces. So from the left, what is the limit as x approaches 3? 3. So up here on this guy. As x gets closer and closer to 3, our y values will get closer and closer to 3. I mean, except they're going to equal 3 because it's a horizontal line. Equals 3. So now we're going to do when we approach x from the right. If it has the little plus, we're coming from the side of positive numbers, from numbers that are bigger than 3, from the right. So what is the limit as we approach from the right? 2. That's this guy. As our x get closer and closer to 3, my y value is going to get closer and closer and closer to 2. If I had an equation here and I put in 3.1, I'd be real close to 2. If I put in 3.00001, I'd be real close to 2. It's getting closer and closer to 2 as the closer and closer I get to my x of 3. So then, what is our limit as we approach 3 in general? It doesn't exist. I have 2 different numbers from my left and from my right. I'm approaching different places. Those 2 paths do not cross.
Will it always be definite?
Not always. I promise we will see one that does. So this one does not exist. And if you want to put like DNE for does not exist, that's fine. I'm absolutely fine with us taking a shortcut of DNE. Valid. Does not exist. A lot of times we will have limits that don't exist, especially when we're looking where we have a jump discontinuity. Questions on those 4? 3 more on this, or 1 more set on this graph. Very similar. We did when x is 2. We did when x is 3. Now we're going to do when x is 4. So first thing we're going to find is we're going to find g of 4. What is g of 4? 3. We're looking when our x is 4. That's this guy right here. So our g of 4 is right there. So what is the limit for g of x as x approaches 4 from the left? 3. As I get closer and closer and closer from the left, we get closer and closer to 3. So my limit equals 3. What about from the right? Also 3. That's coming from this side. We're approaching that same value. 3. So when I'm approaching from the left, I got 3. When I'm approaching from the right, I got 3. So what's our limit? 3. So the limit from both sides is 3. That's going to happen whenever we have something that is continuous over the point we're looking at there. Or if we have a removable discontinuity, we will also have a limit there. And we'll see that on the next page. I just wanted to make sure we saw one like that. Okay, we're going to practice this again. We have a whole nother graph to look at. Very similar vibe. This is our graph over here. Oh, you did get a good quality graph. My one in the notes is terrible quality, but that's okay. I just have my old version has terrible quality graph. All right, bless you. So this is our new function. This is our new g of x. They're not always going to be g of x. I don't know why I use g of x on both pages. Might be f of x, might be h, any number of letters. There's ways to make it more than 26. All right. So this one, it's not organized in quite the same way, so we're just going to need to be careful. So we want to know what the limit of g of x is going to be as x approaches 4. So look at where x equals 4. That's going to be this guy right here. What's the limit as we approach x from the left? 2. What's the limit as we approach x from the right? 2. I can approach the same number from left and right. That means our limit as we approach 4 is exactly what this value is right here. That is our limit. So if we're in the middle of a continuous segment, it is what it is, and it is exactly this value right there on the line. Equals 2. Because our limit coming from the left and our limit coming from the right are exactly the same. I'm going to do these in a slightly different order. I'm going to do the third one next. I'm going to jump down to do this guy right here. As x approaches 3 from the right, what is our limit? 2, because we're getting closer and closer and closer to 3. So our limit as we approach g from the right, or 3 from the right, is 2. What happens as we approach 3 but from the left? You're right, it is a continuous discontinuity. I would say I heard that it was continuous. So I'm going to think about, I'm just going to grab, we're looking right here. So what is it approaching? Oh, I heard it. Negative infinity. It's going down. I'm yelling timber. It's going down to infinity. Like, it is falling fast. The closer I get to 3, the more negative this is going to get. If I put in 2.9, I'm going to have a very small number. If I put 2.999999999, boom, way down. So as we approach 3 from the left, we approach negative infinity. Because that sucker is falling that way. It's going down. So then what is our limit as we approach 3? It doesn't exist because negative infinity is not the same thing as 2. This does not exist. And again, totally fine to put D and E. You can write out does not exist either way. Okay, questions on these 4? What in the ferret noise was that? that? Shoes probably makes way more sense, but like my brain just went, what animal? I'm like a fair going. All right, so here's that middle column of questions. So now we're going to look at 0. What is our limit as we approach 0 with a minus sign? Negative infinity, because that's looking at 0 from the left. That's this guy over here, and it's going down. So it's going to be negative infinity. What happens when we approach 0 from the right? Positive infinity. Going up that way. So what's the limit for 0? Does not exist. The limit does not exist. We don't always necessarily give you finite numbers, but specific numbers. Sometimes we will ask a limit as we go to infinity. So what happens as x gets bigger and bigger and bigger, as x approaches infinity, what happens to our y? It's going to stay at 4. Because we have a straight up horizontal line right here with an arrow. That sucker is going sideways. No matter what happens, this guy is continuing. I could grab my little line here and I could continue it out. This is still going. It's got that arrow on, it keeps going. It's not going up. We don't have any curve to it. This is clearly established as a horizontal line. If we had a curve, then we would have like infinity or positive infinity. But when we have this straight up horizontal line, it's just going to stay there. So as we're approaching infinity, because we know this is a horizontal line right here, it's going to stay at that value. So it's going to stay right at 4. Okay. Questions on these 4? These 2. Because this little horizontal line up here, when we continue it out as x goes to infinity, as my x's go more and more and more and more and more, we're on this line where y equals 4. This guy right here. And it just continues out further and further and further and further and further. But this is the same line on 4 right here. It's just starting right here and going that way. Okay? I love these little magnets. Those are fun. Okay, good question. One more column this up. And then we'll look at the little words at the bottom. And then we'll be done. All right. So, a couple more kind of random ones. What is the limit as x approaches negative infinity? What do we think that might be? Say a little louder. Positive infinity. Because as x approaches negative infinity means we are looking that way. I want to go more and more and more left. It's going to be a test of height. I want to say, okay, I want to go more this way. I've got this line. Yardstick. Too short. It's still going. It's going more and more and more and more. I just run out of arm. Still up there. I'm sure. So it's still going. As x goes further and further negative, this goes further and further up. So our limit as we approach negative infinity is positive infinity. A lot of times looking at limits as x approaches infinity, it will be positive or negative infinity. Occasionally it will be a natural number, but more often than not, it's an infinity. Then let's look at our limit as x approaches negative 2. Because when our x is negative 2, that's over here. If we approach from the left, what's our limit? 3. If we approach from the right, what's our limit? 3. So what's our limit? 3. But what is the value at negative 2? It's a hole. There is no value. It's discontinuous. So I don't actually have a value at g of negative 2. But on either side of negative 2, it's real close to 3. If I didn't have that discontinuity there, it would be 3. So that's a lot of times when we use limits is when we have something like a discontinuity, because we're going, I want to know what that value would be. So I have to look on either side of it to see what's really close. How about our limit as x approaches 5? So I heard 2 answers there. Let's see what else we got. It's like I've heard it the correct one a couple of times. It does not exist. Because if I come from the left, our limit is 2. If I come from the right, our limit is 4. 2 and 4 are not the same thing, so it is not the same limit, so it does not exist. What about our limit as x approaches negative 5? Yeah. If I approach from the left, we get 0. If we approach from the right, we get 0. So our limit is 0. 0 is different than not existing. 0 is a number. So do not think we can put down 0, meaning there is no limit. It's not the same thing. 0 is a limit. It exists. I can point to 0. It's right there.
For number 3,
Uh-huh.
I thought it would be 4 because of the discontinuity.
That would be if we had g of 5. So if I just wanted to know the value of g at x equals 5, you'd be absolutely right. Or if we were looking at the limit from the right, it would be at 4. But since it is a different limit, if I come from the right and from the left, I don't have a limit here. I have a value, but I don't have a limit.
Oh, so it's different if it's like, oh, okay.
Yes, yes. The value does not have to be the same, just like we had on this guy. It doesn't have a value at all. It is undefined right here. But I can still find the limit as we approach it because I know it's happening on either side. If I didn't have a value here, it would just be like undefined the whole time.
Is there an asymptote at x equals 0?
Yes. Yeah, that would be an asymptote at x equals 0. Because these are always going to be functions, so it will have to pass the vertical line test. So I could not have something that went infinitely that way without instantly becoming a non-function. So this would be an asymptote here. All right, we have just a couple more questions on that page. Just remembering some of these things. Because it's been like a week since we met. So we've talked about these pieces before and what words we meant here, but I'm reminding us because, it's a thing. So is the function continuous at x equals 0? No. When I trace along, if I get to x equals 0, I have to pick my pen up to go to the other piece and cross 0. If I have to pick my pen up when I'm tracing it, it is not continuous. So no, this is not continuous, but what kind of discontinuity is there? It's an asymptote. Do you remember what that kind of discontinuity is called? It had a special name. We had our removable. We had our jump. If you put asymptote, I would be totally okay with it. It's technically called an infinite discontinuity. But that's what happens when we have an asymptote. I would actually take that too. So it's an asymptote, But it is an infinite discontinuity. That is the technically better name. But I would absolutely take asymptote. Discontinuity. That's looking at, just so that we can track stuff, that's looking right here where x equals 0. Is the function continuous at x equals -2? No. So again, we're looking at -2. That's this guy over here. If I trace along, I have to pick up my pen and jump over that hole at -2. If we are tracing along it, think of it as like a little pit of lava. On a bridge, on a bridge, on a bridge. Ah, jump. I had to jump over it. So if I have a discontinuity there, it means it's not continuous. So there is a discontinuity. So no, it is not continuous. What kind of discontinuity is that? Removable. It has been removed. It's been plucked out of the line. This is a removable. Discontinuity. Also known as a hole. It looks like somebody stabbed it. And then our third one over here that we're asking about is what happens at x equals 5? Is it a continuous at x equals 5? Nope. What kind of discontinuity is that? It is a jump. It has a jump discontinuity. I'm going to not write the word discontinuity again. 1, because I'm out of space. 2, because I don't want to spell it again. You can just put infinite, removable, and jump. Like, you don't have to write the word discontinuity. Too much spelling. Okay. So the discontinuity stuff we've talked about before. It's just been a minute. The limits, especially when we're looking at pictures, aren't brutally awful. Tomorrow we're going to look at those equations on the next page. I promise they're not as bad as they look. But since limits are not really done super awesome in the textbook because they are in about 7 different places in very bizarre small segments, I have made us a worksheet. Make sure I'm not doing that. So there is a picture on the front with questions just like we did. And the bottom half has another picture. So the only ones that have equations are these top ones on the back. And that's what we're going to talk about tomorrow. Okay, so here's a worksheet. You don't have to worry about the textbook on this one. So I'm going to pass these on. And you guys can have the remaining 7 minutes, 8 minutes, to start on it if you want to. Or if you want to do your chapter cuts, you can do that. Like I have them. They're all here. So if you want to do chapter tests, now would be a great time to do it. If you just want to work on this, that's a great time to do it. All that jazz. I'm going to put this page on the end. So this worksheet's going to be due on Wednesday. Our next chapter test is November the 7th. November 7th.